Hello again. Today we're going to learn about a new way to graph. Up to this point in math, we've been using what's called a rectangular coordinate system. Sometimes it's also called a Cartesian system, after René Descartes. And these are the sorts of points which come in the form of x comma y. Today we'll be moving into a new coordinate system, and that system is called the polar coordinate system. So in the Cartesian system, if we had a point, say -2 and -4, the first values are x, the second is our y, and so we would go 2 to the left and 4 down, and we would plot our point about right there. The polar coordinate system is different. In the polar coordinate system, we don't have an x and y. You can see it's not rectangular, it's more circular, and it involves distances and rotations, as you're going to see shortly. So instead of having x and y, we have an r and we have a theta. Now this r could stand for radius. It's the distance that you are away from the center of the graph, the center being right here. And this theta is the angle going from this, what used to be our positive x-axis, this location right here. It's basically where on the unit circle where 0 degrees would be. So there's a relationship between the unit circle here and this polar coordinate system. So let me give you an example. Suppose that we've got 3 comma pi over 4. So our point is going to be 1, 2, 3 units away from the center, and it's going to be a pi over 4 rotation going in the counterclockwise direction. Now, just to let you know that we start here as 0 degrees or 0 radians. Each of these lines represents 15 degrees. So this would be 15, 30 degrees, 45 degrees, and so on. So 45 degrees equals pi over 4 radians. We know that, and so let's start out 3 units away, which would start us out about right here, and then rotate it pi over 4 radians, or 45 degrees. That's going to land us right here. And so this is where our point 3 comma pi over 4 would be located. Let's scroll down a little bit. Let's graph this point, let's graph this point 2 comma 2 pi over 3. So remember that 2 pi over 3 let's get that pen back. 2 pi over 3 represents 120 degrees. So this would of course be 90 degrees. Each of these lines is 15 degrees. So 120 degrees would put us right there. And so we would go out 2 units, rotate it 120 degrees, and our point would be right here. Next. With this one, we've got a little different because we've got that negative there, and I'll tell you what to do with negatives. So what you should do is just think about this as plotting the point 3 comma 5 pi over 4. Now this 5 pi over 4, convert it to radians. From radians to degrees is 225 degrees. So start by plotting that. 225 degrees would be here, 2 and 3 units out would be right there. Now, since this is a -3, we're going to go, instead of this way, we're going to have to go to the opposite side. So in that sense, it's going negative instead of going the positive 3 units. So you're going to basically flip it the totally other side. You can think of it as spinning around 180 degrees if you want to. So that's going to put us at this location, 1, 2, 3, right here. Next up. You'll also be asked to take a point on the polar coordinate system and then write 4 different coordinates for that point. Alright, so looking at this red one here, we can see that it's 2 units away from the center. So we're going to have 2 units followed by a rotation. And so I'm going to start at this location right here. Start right here again. Spin 90 degrees, 180 degrees, and then another 45 degrees. That puts me at 225 degrees, which, remember earlier, is 5 pi over 4. Now there's another way that we can write this, and that would be by, instead of spinning counterclockwise, we would spin clockwise around. Now when you spin clockwise, remember from earlier this year, a clockwise spin is a negative angle. And so this would be a negative, think about it as 360 minus the 225 that we already did, so that would put us at 135 degrees, but it has to be negative because we're going clockwise, and so that's going to be a negative 3 pi over 4. So those would be our first 2. Now let me erase what I did right here. Alright. Now we've got 2 more. Got 2 more where we would have a negative 2. So to do the negative ones, go to the opposite side of the circle, in this case, going 180 degrees around. So this would be with a positive angle, 45 degrees, which would be pi over 4. Then to get to the same spot with a negative turn, pi over 4. Same spot with a negative turn, you would be going 315 degrees around. And that would be a negative 7 pi over 4. So those are the 4 ways to give polar coordinates for that point. I'm going to pause the video and let you try the next one. Welcome back. Here we've got the 4 ways for you to plot here. Let me start over again. Here we've got 4 ways for you to write the polar coordinates for this blue point, our second blue point on this axis. Alright, let's move on to the next topic. Alright, so to convert between the polar coordinate form and the rectangular form of a point, we need to remember a few facts. First off, let's remember that the cosine of an angle is the x over r, that sine is y over r, and that tangent is y over x. So from there, we can take this first equation, this cosine theta equals x over r, and multiply both sides by r. When you do that, that's going to look like r times cosine of theta. If we multiply this second equation on both sides by r, we're going to have y equals r times the sine of theta. And then this last one is related to the Pythagorean theorem. Basically, if we've got an x here and a y here, Pythagorean theorem says that this is going to equal r squared, the hypotenuse squared. So let's keep those in mind. a second. Alright. Just keep that in mind when we do this next thing on your next page. So this part says find the Cartesian coordinates of a point with polar coordinates. Okay, that grammatically doesn't make sense. Let me change that up for you right here. There we go. Nice. A little better anyway. Alright, so we've got the point 4, 5 pi over 6. So we're going to be out here at the edge, go around to 150 degrees. That's going to put us right here. So we want to find the Cartesian coordinates. So to do this, remember that the Cartesian coordinates are the x, y coordinates. And we just said at the bottom of the last page that x is the same as r times the cosine of theta, and that y is the same as r times the sine of theta. So let's substitute. R, it tells us, is 4. So we've got 4 times cosine of our angle, which is 5 pi over 6. Do that same thing for sine. And then we evaluate the cosine of 5 pi over 6. Let's remember 5 pi over 6, 150 degrees. We're going to need to draw a 30 degree triangle to get us to 150 degrees, like that. And so we'll have a 1, 2, and negative root 3. And so the cosine is negative root 3. Negative root 3 over 2. And then let's multiply those together. 4 over 1. We can cancel out a 2 from that 4. Cancel out that 2 on the bottom. And we're going to have 2 times negative root 3, which is negative 2 root 3 over 1. And then for sine of 5 pi over 6, the sine is opposite over hypotenuse, so we've got 1/2. And 4 times 1/2 is 2. And so our first rectangular coordinates are negative 2 root 3, 2. Alright, let's do the same thing for this one. Alright, now remember we've got a negative right there, and so let's plot it as though it were positive. So we're going to go out 2 units and then do a pi over 2 spin, which would be 90 degrees. So it's going to put us right here. Now, our x and y is our cosine theta, our sine theta. So r is negative 2. Theta is pi over 2, so let's plug those in. Now to do pi over 2 or 90 degrees, we can't do a triangle, so you either need to go to the unit circle or remember the cosine graph. So either way, the cosine of pi over 2 is 0, and the sine of pi over 2 is 1. Multiply, and we have the coordinates 0, negative 2. I'm going to pause here for just a second. To find the polar coordinates of this first point, let's first plot it, then make a triangle out of it. When we do that, we can see that we've got a 3 and 4 unit side, and if you use Pythagorean theorem, you can get the fact that this hypotenuse must be 5 units long. And so the radius then of this point is going to be 5. Next, what we need to do is we need to find what angle takes us over to this point right here. So I'm going to stop this first video and then we're going to finish things up in part 2.